All right, so welcome to the day 2 of the machine learning project. So if you're watching this video from YouTube, you're welcome. And for those in class, you're also welcome. All right, so today's topic, we're going to be looking at EDA, which stands for Exploratory Data Analysis. So we're going to be understanding the importance of EDA. All right, so this is a key concept in machine learning pipelines. Let's look at the learning outcomes. By the end of this course, you should understand the importance of EDA in AI pipelines and its impact on model performance. You should be able to identify key terminology relevant to exploratory data analysis and its application in data science. Thirdly, by the end of this course, you should be able to explore the household power consumption dataset and learn how to interpret its structure and content. And finally, you will learn the techniques for loading data with Pandas and performing initial inspection to address data quality. All right, so what role does EDA play in improving machine learning models? So we'll talk about the significance of exploratory data analysis, as well as the impact on data-driven decision making. Now let's look at the definition of EDA. EDA is a systematic approach to summarizing a dataset's main characteristics, often using visual methods before applying formal modeling. Now that goes to say that EDA is the detective work of data science. It involves descriptive statistics, visualizations, and data quality checks that helps you form hypotheses, spot anomalies, and choose appropriate modeling techniques. Now we'll go over to the key terminology in EDA. Now we're going to look at terms such as features. Now you must have heard of features in machine learning. Now this is a measurable property or variable used as input to a model. All right, for example, you might be given a price of a house, and you might be asked to determine what price a house can be sold for, considering different characteristics and attributes. So these attributes or characteristics are described as features. It could be the size of the house, it could be how many rooms in the house, it could be the location of the house. So these are attributes that can determine if the price is going to go high or if it's going to go low. So these are features. All right, so the next term is observation or record. You've often heard this term, observation. It's a single row of data representing one measurement instance. For example, you have a data set, a structured data set in Excel. Now, for each row that you have in that Excel, it's considered to be an observation or record. So if you have 10 rows, it means you have 10 observations or records. So these are entries, okay? These are data entries for a single person or a single case, depending on the situation or the nature of the data set. Now let's go over to missing value. Missing value, which is also known as none. Okay, so we describe this as unidentified or unrecorded data points. In your data set, you might have some missing values, you might have some data points or a part in the Excel where some columns are missing. You have missing values, which are represented either with a question mark or none. So it means that particular data point is undefined or it's not been recorded. And then you have the outlier. Outlier is the data point that deviates significantly from other observations. All right, so, and then we have summary statistics. This could be considered as mean, median, standard deviation that actually capture characteristics of a distribution. We have another important term which is known as time series. Time series is nothing but a sequence of data points indexed in chronological order. And then we have resampling. Resampling is nothing but aggregating time series data to a new frequency. E.g., it could be resampling hourly to daily. And then we have z-score. Z-score is known as a standardized score showing how many standard deviation a value is from the mean. All right, so let's look at exploring the data set. All right, so we're going to be exploring the household power consumption data set, which is a .txt file. So this data set provides a comprehensive look into daily energy usage patterns over time, capturing critical insights for analysis in various contexts. Now let's look at capturing the essence of data handling with Pandas. So initial data inspection, analyzing insight for effective EDA. Right, so the initial data inspection is crucial in understanding your data set. All right, so there are methods we can use, such as the info and the scribe method. This is very important because you need to understand the nature of your data set before you can determine what modeling process or procedure you need to embark on. It's very important that you understand the numbers of features that you have and what exactly are you looking out for. All right, so you can gain insight into data structures, types, and statistical distribution. So this enables you to make informed decisions when exploring your data. And don't forget, Panda is a very powerful tool that can help us achieve this task. Loading data with Pandas. Now we will work with the household power consumption.txt dataset. It's a public dataset that records active power in kilowatts, volts, and sub-meter readings at 1 minute intervals. So we're going to take a look at the characteristics of this dataset. Now this dataset has 8 columns. It has missing values represented with a question mark, and these entry points are separated with a delimiter, which is also known as a semicolon. Right, so we have this column, which is nothing but the names of the attributes. We have the date, time, global active power, the global reactive power, voltage, global intensity, and sub-metering 1, 2, and 3. All right, so we're going to look at few parameters such as the pass date, null value, and low memory. So the pass date is actually a parameter that tries to merge time and date into a single date time index. So this is essential for resampling. And then we have the null values. All right, so convert question mark to null for numerical operation. Now we have the low memory, which avoids D-type guessing problems on large files. Now, let's take a look at the comparison between the missing value handling techniques, such as the imputation versus deletion. Now, what are the key differences between imputation and deletion method in handling missing values? All right, so let's take a look at this. Imputation fills in missing values based on statistical method. So this is what imputation is all about. For example, you have a missing data and you want to impute some values that could be close to the original values using some statistical method. It could be the mean, okay, it could be forward filling, it could be other method. All right, so we have deletion. A deletion is a process where we remove the records with missing values. But one of the challenges is that this can lead to data loss, especially when you don't have huge amount of data. If, for example, you have a data that consists of 1,000 observations, meaning you have 1,000 rows, and you found out that you have a missing data point of close to 500 or let's say 700. In that case, deletion will not be a good option because you're going to be losing a lot of data. So you're rather going to use imputation, okay, which you can apply forward fields or some other statistical method, all right, to impute or generate some data point that might be close to the original, what it might be or what it should be. Now let's look at the advantages and the intersection of both. Now both methods aims to maintain data integrity and also analytical validity. So that is the essence of both methods. So whether you're deleting, whether you're using imputation fields, all you're trying to maintain data integrity. All right, so what are your preferred method for handling missing values in dataset? So this is based on the nature and the sensitivity of your project. Now, if your project is not for a sensitive sector, then deletion might be a good option rather. But if it's a very sensitive sector, imputation field might be also a good option. Now that depends on the nature of the project, that depends on how sensitive it is, and that depends on the decision of the domain expert as well. All right, so imputation techniques such as mean, median, and more can be used, and then exploring the impact of outlier detection method. It's also a good approach. All right, so understanding methods for handling missing values. Now let's dive into imputation techniques. Now we're going to explore the various strategies to improve the data. Imputation techniques for missing values. Now imputation techniques such as mean, median, impute, and forward fill are essential for effective data analysis. Understanding this method ensures robust data set for accurate machine learning models. Now, outlier detection methods. We have the Z-score and the IQR techniques. Outlier detection is crucial for data quality. The Z-score method identifies data points that deviate significantly from the mean, right? So while the IQR method calculates outliers based on the interquartile range. Both methods helps in maintaining the integrity of machine learning models by filtering out anomalous data points. Now, when we talk about outliers, we're talking about data points that is significantly deviates from the mean. All right, so sometimes you can have a cluster of data points, and then you can have some data points that are far away from these clusters. So this can be considered as outliers. Now, visual exploration enhances understanding of data distribution and help identify key insights. So it's very important after using Pandas to explore your data. It's very good to visualize this data for you. Want to be able to understand the data distribution on a plot. It could be an histogram plot, it could be a scatter plot. It's very important that we understand the distribution of the data points that can also help us identify key insights into the data. Now, understanding resampling and seasonality in data analysis. Resampling techniques such as hourly and daily resampling allows analysts to convert time series data into various frequencies. This method helps identify patterns and seasonal trends. Understanding the combined EDA workflow for effective analysis. Key components and their connections in the exploratory data analysis process. Now, let's look at visualization tool and techniques for deeper understanding. So this is what visualization helps us achieve. It's in form of a graph, a plot that helps us or that provides a deeper understanding of how the data points are distributed. And then data cleaning techniques and methodologies. So cleaning process is a very crucial step in data exploration, taking out missing data, and then ensuring that data integrity is achieved. And then the shared focus on enhancing data insight and accuracy is basically the goal of the combined EDA workflow. Now my encouragement is going to be for you to engage with these hands-on exercises to enhance your understanding of EDA techniques. So we're going to be having hands-on exercises. You're going to practice all of this for you to have a better understanding on how exploratory data analysis is carried out. All right, so thank you for your attention, and let's continue exploring EDA together and uncover valuable insight through data analysis. Thank you, and see you on our next day of our machine learning project. Goodbye.